Let's discuss the first law of thermodynamics now. We're going to be defining the first law of thermodynamics. We'll discuss how the internal energy of a system relates to the sign of the energy and the sign of the energy transfer. We will discuss heat and work again in a slightly different manner than in the simple definition form. However, we're still going to be covering those later in more detail in their own videos. Internal energy is the total energy a system has. Since we only have kinetic and potential energy, this means that the sum of the potential and the kinetic energy is equal to the total internal energy. It's important to know that this is a state function and therefore doesn't depend on the path taken to gain or lose energy. This also means that we can find the change in energy based only on final minus initial. Now, let's talk about the first law of thermodynamics itself. While the internal energy of a system can change, the total energy of the universe can't. This is the first law of thermodynamics. Energy is only transfer. It is neither created nor destroyed. Let's think about grass. It gets its energy from the sun, and a bunny comes along and eats the grass. The bunny isn't making up energy from anywhere. It's getting it directly from the grass. And he now has energy to hop and skip and play. This is transferred into a variety of different energies: heat energy, kinetic energy, among various others. Of course, baby foxes need to eat to live too, and so sometimes this energy gets transferred into the fox, so that the fox can also run and skip and play. At each stage, energy is transferred in a variety of ways, but the total energy of the universe remains constant. Now we need to talk about the energy transfers, and to do that we need to talk about signs. Whenever we are talking about energy transfers, we need to know if the energy is coming into or out of the system. Think about a bank account. If you put money into a bank account, the change is going to be positive. If you take money out of the bank account, it's going to be negative. This is identical to what happens with energy as related to the system. If you put energy into a system, its change is going to be positive. Now, the surroundings are always the opposite sign, and so the surroundings energy will be negative. The opposite, of course, is true too. If you take energy out of the system, you are removing energy from the system, and the change is negative. Because the surroundings change is always opposite, the surroundings change will then be positive. So think about your energy changes, signs, being the same as a bank account when you are talking about the system. You put energy in, it's positive. You take energy out, it's negative. Remember in earlier videos, we said that there are two types of energy transfers: heat and work. Since these are the only two energy transfers, we can write this as an equation where delta E is equal to Q plus W. The signs for these match up with what we said about energy. If Q or W is positive, that is putting energy into the system. If Q or W is negative, that is taking energy out of the system. We have slightly different ways of phrasing that for work. We say that work is done by the system if it is losing energy, or work is done onto the system if it is gaining energy, but the signs are still the same. Now let's do some practice with identifying things as heat or work and determine the signs of each one. They're both going to be discussed more in depth in later videos, but we can already identify which is which. Remember, heat is transferred because of a difference in temperature, while work is force acting over a distance. Let's start with sweat evaporating from the skin. It cools the skin. I tell you that the system is sweat. This way we know what exactly we're talking about. So our heat is transferred from our skin into the sweat. So it's heat energy. Overall, we're talking our system is the sweat, and it is gaining heat, and so it is gaining energy, and so the change is positive. A balloon expands against an external pressure. So take a second and think about this one. In this case, we have a force acting over a distance. The balloon is expanding against the force of the pressure pushing it down. And so that is work. Now the balloon is doing the expansion. The balloon is pushing out. And so therefore the balloon is doing the work, or the balloon is putting energy into the surroundings. And so the overall energy change is negative. To the system, so the system is gaining energy, delta E is positive.